back to an episode of the Open Source Cafe. And today we're talking about Kubernetes troubleshooting. And we have Itiel here with us. Itiel, thanks a lot for joining us on the channel. Would you like to tell our viewers a little bit more about yourself?
Hey Kunal, happy to be here. So my name is Itiel Schwartz. I'm the CTO and co-founder of Komodor. We are a startup designed to help dev and DevOps to troubleshoot Kubernetes much more efficiently and faster. Before founding Komodor, I was a developer and what is called like a DevOps. I did a lot of infrastructure work. I've worked in small companies and big companies such as eBay. And I work with Kubernetes over the past 5 years, I think, or 6 years. Really love the technology and love the ecosystem as well. That's me in a very, very short.
Amazing. Well, thanks a lot for joining, and definitely we can learn a lot, from your experience. And since today we're talking about like Kubernetes troubleshooting and folks who may be new to this term, what does it actually mean?
I think Kubernetes is designed to run like containers, right? Like it's a container orchestration platform. So you try having your application and throwing them into like Kubernetes and hope everything will work as expected. Sadly, in the real world, as everyone know, things doesn't really work as expected. Your application crashes, it doesn't load, it doesn't get enough network, requests get lost. There are a lot of different failure scenarios. And when I say troubleshooting Kubernetes is, I'm meaning from the second you feel or you get alerted that something is not working as you expect until the moment that you fix the problem and everyone is happy. And Kubernetes, because it is so complex, sometimes it takes a lot of time, like going over like this journey for each instance of like alert or problem.
Yeah.
So, yeah.
And it's also like not just the issues you're having right now, but I think also taking measures into account to prevent such issues from happening in the future, like learning from your mistakes and scenarios and things like that. Speaking of which, when we're talking about Kubernetes troubleshooting, what are like some of the aspects to make it more effective when you're working with Kubernetes?
I think like the main thing that you can do in order to make it effective is to think about things in advance. Like sadly, if you think about troubleshooting for the first time when your application is like running in flames, you're probably too late. Like there is a very big aspect of preparation, having both the mentality that your application is going to break, but also having like the mentality and the tools required in order to make sure that you will know about things before they break. So I will say, I'm going to talk a little bit more about like how to troubleshoot and a little bit about the pillars. But it all starts with the preparation work that you do in advance. So once an issue, a problem will occur, you will be able to fix it as fast as possible. So I think like that's pretty
Yeah.
much it.
Yeah. And let's talk about the pillars while you mentioned those as well.
Yeah, so as we see, there are like three main pillars of like troubleshooting or like incident management. So there is the understanding of basically understand that you have a problem, knowing that your application is down, that users are unhappy, that you take a lot of time to respond. It doesn't really matter, but there is this very important step of admitting that something went wrong in the world. So I will say that like this is where issue starts, like when you understand that you have a problem. Then you have the manage part, meaning given a problem, given an issue, how can I fix it as fast as possible? How can I like how can I make sure like things are back to normal? I will say in here, like usually there are like two different approaches or like two different steps you sometimes takes. There is the bandit, mainly like making sure that your application is now it was down and now it is up. For example, you can just revert the code or something like that, and then everything will work back as normal. And there's also finding the root cause itself, like finding what was the problem. I don't know, like a bad line in a Python file or something like that, and fixing it and like giving like proper remediation. But usually, from my experience, and I think like that's the agenda, you need to make sure the house is not on fire before you really try to find the root cause if it takes too much time. Like if you know what is the root cause in a heartbeat, then great, let's fix it. But the first thing first, and it is the system stability, availability, and performance. So this is where we start.
Amazing. I love that how you have mentioned about, like, first you have to understand the issues. So I believe tools like monitoring tools can come into picture with this, and like logging tools and things like that. What you mentioned about management. So in Kubernetes, we often deal with microservices, for example, right? And in production, what I have seen is there are many teams that are working on various different components, and something breaks. So I think, like, if you're working with multiple teams, communication and collaboration is essentially the key. So how would you, from your experience, could you like share a little bit more about that?
Yeah, yeah,
How,
sure.
teams can work together.
I'll give a couple of tips. I will say the third pillar is prevent. I will talk about it later, like after the incident is already done. What can we do? What can we learn, and so on. But let's focus on the manage part, because I think it really it is very tricky. Like in the end of the day, it is very tricky. And in order to know that you have a problem, it is also tricky. But there are tools that are quite good at this. Like if we look at like Datadog, Prometheus, New Relic, they know to alert us on on a lot of the different failure scenarios in Kubernetes. And I think like this is like the problem is a bit more like concrete. When it comes to managing, I can share with you like our product help dev and DevOps to troubleshoot issues, to solve issues. And a lot of the times we ask people like today, when you have a problem, how do you know what team is responsible for like managing the problem? You are in a large organization. Like you said, there are like multiple teams, multiple there's the dev, there's the DevOps. How do you know? How do you know who to alert? So usually how it goes, we ask them that question. And the first question is the first answer is usually, yeah, it's not that problem. If it's an infra problem, then we like move it on to the infra team, the SRE team. If it's an application issue, then we like route it to the application team. But then I'm asking like the next step, like in after day, a lot of the application errors are caused due to database problems or due to problems in other teams, right? Like there is the ripple effect, the butterfly effect in microservices. How do you know? How do you know that this application problem was not originated because the SRE has done something wrong? And then usually what happens, most people are like, oh yeah, like to be honest, like 90% of the times when the application team is getting the alert, we also alert the SRE team just in case, because a lot of the times it's their fault. So we wake them up just in case. So I think like it's a very big pain point. I think like the solution, there's the technical solution and there's also like the cultural solution or like the process driven solution. In terms of like the technology, as much as you can make sure that there's a single responsibility for a specific team, and just to make sure that things are really like are really like containerized, like contained. Sorry, it is easier because you know that if this API breaks, you need to call this and these teams, and it makes the problem much easier once you have very clear responsibility areas for teams. It doesn't solve everything, but it does helps a lot. And if you have both the responsibilities and also the SLO, the SLA, the things that the team guarantees, it makes like understanding the root cause much easier. Because you know that like if you are dependent on the database and the database currently has issues, you don't necessarily need the application or like all to wake up all of the application developers. First of all, let's go and talk with the SRE team because they're responsible for that. So I would say like this is like the first step, making sure that you have this understanding who is responsible for what and how does it work. So this is like first thing first. The second thing I will say that is very important, like you said, is more about communication. And this is very tricky because there's no very like vanilla playbook to follow most of the times. Each organization is different, each service is different, and the ability to communicate like with other teams is super tricky. I will say that the best tip I can have here is to be very transparent. You need to be transparent about what you are currently doing in order to solve the issue, and what do you believe is the root cause in each specific problem. And when I say you, it can be like multiple teams that are working and have different theses on what is the root cause of the problem. But I think it is something that a lot of the times is not enough in the focus. You can say, for example, I'll try to give an example. The website is currently not working. Okay, so you wake up the guy or the girl who is responsible for the website, and you tell her, "Hey, the website is not working. Please fix it." And now she starts to investigate. Maybe she goes to Datadog. Maybe she go to Komodor. Maybe she go to to Kibana, but she needs to communicate what she is doing and what she believes is the root cause. For example, she can say, first of all, I'm checking in Jenkins if there was any change in the last hour. Okay, interesting. I'm checking to see if all our requests to the database are in like good latency. I'm checking in Sentry to see if we have any errors, because maybe there's an application error. So I think in order to make sure things work like as expected, you need to be very transparent and very clear about what you are doing, and like make sure that people can jump in and tell you. And that is like the key to make sure that complex issues are like solved quite fast, because someone from a different team might say, oh, we changed the API like 5 minutes ago. We send you a message over email. Didn't you get it? Or something like that. So once you are very transparent and very clear about what you are doing, I think it gives a lot of other people the ability to make sure like this works as expected, and to help you make sure this works as expected. So I think like that's like there's the technical part, which is not simple, and there's the cultural part, which is also not simple. So managing incident in complex issues is hard. I guess like a lot of your listeners might like read the Atlassian postmortem that they just released. Super interesting. A lot of like different failure scenarios and problems. I think communication was like one of the second point that you brought as like on that specific issue. So I think like super interesting.
Yeah, I love the point you mentioned about the team culture, because it's extremely important. Like once you have identified the issues, and then you're trying to work around with it, and let's say that issue comes on, like keeps on happening again and again, so you may be able to document it in a certain way that other team members may be able to resolve it. Or like you have a Kubernetes operator that automatically is triggered whenever that particular issue happens, things like that. But we'll talk more about like the technical tools and a little bit more about Komodor shortly. But yeah, I love it that we're talking about the team and communication practices. I think it's a very very important topic. Cool. And would you say that this is also the communication thing that we just spoke about? Would you say that this is also one of the reasons why some folks may think that the K8's troubleshooting is hard, if you will?
Yeah, I think it's one of the reason. I think like in the end of the day, Kubernetes and people really don't understand it. It's not like it's not a magician. Like it doesn't write the code for you. It doesn't like fix all of your problems. It allows you to horizontal scale quite easily. It has self-healing. I really like Kubernetes. I think it's great. But in the end of the day, it captures a lot of the problems or a lot of the issues that you may encounter even without like Kubernetes. And if your team had issues, for example, like troubleshooting or solve issues before Kubernetes, and now you just migrated to Kubernetes, take into account it's probably going to be harder to troubleshoot, not easier, because you don't know Kubernetes and it's hard. So once you have distributed team, distributed network, distributed people, like things are going to be hard. I think people see Kubernetes, at least at the beginning, is like a black box that you just throw everything and Kubernetes will make it work and it will be simpler to troubleshoot or to debug. And then they really install Kubernetes and then they understand that it's not that simple and it's not that simple. Because it just made like other things like easier.
Yeah.
Mm-hmm. So
Yeah,
yeah.
I agree. So that's basically about it, right? It's hard. That's fine. It can become a mess, but you
Mhm.
have to have like good coordination in your teams, and you should have access to the right tools. So we talked
Mhm.
about coordination part. Let's talk a little bit more about the tools, right? So tell us a little bit more about, like some, like I've used valid queue for example. So
Mhm.
can what that has to offer, and some other tools that you'd like to share about, and what your teams use, and then we can talk about Commodore as well.
Yeah, so the themes that we like or I can recommend, like ValidQ is a very nice open source project that we release in order to validate YAML files and to find problems or security gaps before you go into production. Like I said, like earlier, like preparation is the king when it comes to troubleshooting or like solving issues. I really like. I think like metrics is like the obvious thing that you must have if you are like in Kubernetes. It goes without saying. Like having Prometheus or like we really like Datadog as well. Like I think they have a really good product is super important because the first thing you need to do, like I said, is like to own the fact that you have a problem. And I think like Prometheus as an open source gives you exactly that. Prometheus and Grafana usually. Datadog is one of the best like paid solution that I can recommend. When it comes to login, I'm a long time like Hibana fan. I tried Loki a couple of months ago for the first time. It was interesting. Like I like the Lucene like syntax and UI and so on. So I might be old fashioned, but Loki or Luki, well, how do you pronounce it? Like
I think it's
correctly?
Loki.
Loki. Sorry. So like Loki seems like a very interesting like solution. Didn't try it like hardcore in production solving issues, but it does look promising. And I think like Splunk is the obvious like third one that a lot of the companies are using when it comes to logging. And the third tool that I think is very important, especially like you said in distributed system, distributed like companies, is tracing tools such as like Jaeger, which I think it's an amazing product. I really like everything about it, the design, the UI, everything. I think gives you a really good solution. And I will say that Datadog also has a really good APM solution. Like we're using Datadog internally when it comes to APM. It works like out of the box, like very natively, and it has like a really nice and good UI. Jaeger, I think like Jaeger and Datadog. I also work with like Zipkin and New Relic a little bit. So there are a lot of like in each category there are a lot of different tools to have like to own. But I think having like tracing, logging, and metrics are like the basic when it comes to solving issues. The fourth one, more for the application level, is error handling tools, Sentry, Bugsnag, Airbrake. Like there are a lot of different good tools in that space as well. I think they are quite helpful, especially for like application developer, not necessarily for DevOps, but they allow you to to pinpoint the issues a lot of the times very fast, and they are quite low maintenance, like unlike logging, which sometimes you can like swarm the login system and then it crashes. Like error handling is less of an issue to maintain.
Amazing. Thanks a lot for sharing it, TL. And I'll leave those like in the description below. You can check it out later on. Yeah, I've been using like quite a few tools like myself, and
Mhm.
there are a lot of people from a lot of companies from Israel who are working on the making the developers' life easier in the DevOps cycle. So
Mhm.
I know Commodore, I know Litri, I know like people from Kubescape, which is a great tool for
Yeah,
like Kubernetes security, open source tool. So I think it's very nice. Should
no, a lot.
visit a lot
Logs.io
of
for
people.
metrics.
Yeah, that's
I
amazing.
I think that JFrog, which started 8 years
Hmm.
ago, I'm not sure like how long. Like Israel was quite there are a lot of like good database companies there
Hmm.
was, and I think the fact that JFrog has succeeded as much as it succeeded, that Snyk as well, really helped like boost the industry here,
Hmm.
and it gives a lot of other companies the ability to strive and like to grow, and it is really cool to learn from other people
Yeah,
in that ecosystem. So yeah, like
nice.
yeah.
Awesome. Speaking of which, let's talk about Commodore, right? For folks who may be new, what is Commodore and how does it tie in with the whole Kubernetes troubleshooting thing that we're talking about?
Yeah, sure. So Commodore, our goal is to simplify the troubleshooting process inside Kubernetes. And we are doing this by, first of all, installing ourselves on the Kubernetes cluster and allowing the users to understand like the thing that I didn't really mention in this talk too much, but what has changed across my cluster, or what has changed not only across my cluster, but across all of the system. Because we know that most issues originate in someone who changed something somewhere that caused some sort of like butterfly effect, and now the system is down. So Komodor first and foremost allow you to understand what is the current status of your Kubernetes cluster of each one of the services and how did the cluster and service change over time. And I will say that this by himself gives our users ton of value because they don't need to play the blame game of who changed what, why. They just go logging into Komodor and understand very, very fast what happened across each one of the services. The second thing that Komodor does very, very well is to give you the root cause for issues in Kubernetes. What we have done is we learned quite a lot over like the last couple of years when we were live, and we saw a lot of different Kubernetes failure scenarios, and we are all a team of like Kubernetes experts, and we know about a lot of the Kubernetes known issues. We automate what like an experienced DevOps would do, and we simply run a playbook for our users for each one of the Kubernetes issues. And that means, for example, that if you're getting a volume that is unable to mount or something like that, we know to check to see if the PVC is having issues because the node failed to load, because AWS is having issues. So instead of the user going into each one of those manual steps, Komodor is running like a set of predefined playbooks for each one of the common issues and allow our users to find the root cause very easily. So we take the troubleshooting like process, which is super complex, super hard. We make it much faster, and we allow people that are not that like DevOps to solve a lot of the issues by themselves. So a lot of the times the ops teams are simply overswamped with issues, with problems. And by using Komodor, they allow the developers to solve the issues much faster by themselves, and they also save time for the DevOps. So like the two main things that we do really well is like first of all give you a full visibility on your current Kubernetes status and history, and also to give you like real root cause for a lot of the common Kubernetes issues and save you a lot of time and effort.
Amazing. And how would you say that it compares with something like Argo CD?
I think Argo CD is a great tool like for deploying code, right? Like I really like Argo. By the way, one of the best tools in the Kubernetes ecosystem. I think when it comes to troubleshoot, Argo can give you the changes that were done only via Argo and very like specific to a specific application. Usually like using Argo in order to troubleshoot, it's nice, but it doesn't give you like the complete picture. It doesn't know how the nodes have changed, how AWS has changed, how changes was done in other teams that are not using Argo. So I will say that there is like some overlapping when it comes to like change management, but usually Argo gives you like a very partial like view on what has changed, and it is not very like easily to use when it comes to very large system and very distributed networks. I think like the design of Argo was not troubleshooting, right? Like they didn't really try to build the
Yeah.
best troubleshooting tool. They built such an amazing CD tools that people are using it to
Yeah.
troubleshoot.
Around GitOps. Yeah.
Yeah, yeah. One again, really good tool.
Cool. Cool. Awesome. Just one last question. What does the future hold for Kubernetes troubleshooting? Do you have any like um, predictions around it and Commodore as well?
Yeah, I think like it's going to get much more complex, like in the future, and hopefully like Commodore will help make it easier. But we see more and more companies moving to Kubernetes. We see
Yeah.
bigger payloads. We see bigger payloads. We see the ecosystem itself are creating more tools to make Kubernetes more efficient, more fast, run database on Kubernetes, which is great. Again, I love the
Mm.
ecosystem, but it will make troubleshooting harder. Like trying to troubleshoot stateful application inside Kubernetes will be even harder, I believe. And I believe Like I see Kubernetes is like a mini cloud. More and more things will move into Kubernetes going forward, and it will probably going to be much harder to troubleshoot in the future. In the end of the day, as much as I love Kubernetes, it is very early on the adoption curve. Most big companies are not running Kubernetes, so like most of the heavy workload, we see the migration wave, and we're still, I think, in the start of it. And as more people will move into Kubernetes and the application will be more complex, I think it will be harder. And like, hopefully Commodore will help make life easier
Mm.
for a lot of the users.
Amazing. Do check out the links in the description below. Just one last pointer. You also mentioned, I think, like, yeah, with companies, for some, it has been like difficult, um, onboarding to kids, simply because they may not be having the rightful skills, and it just feels a little bit more complex. And I've seen like a lot of companies are coming out who are trying to provide that abstraction for folks to work with Kubernetes, like Portainer, KubeSphere, the management tools, for
Mhm.
example. Tying that in with troubleshooting, what are your views around that?
Yeah, I think like it's tricky. It is depend like abstraction is good. Kubernetes is doing a lot of abstraction already, right? And then we're
Hmm.
adding more abstraction layer. It can be nice. Usually, what abstraction gives you is higher velocity because things are easier to set up or to run. A lot of the times, it hurts you when things fail, like because you don't really know what is happening, and then it is really like it's bad, right? So you need to find the right balance. I don't know a lot of like really tools, great tools that like were able to do it. But I believe like maybe like in 5 years, maybe things will work. I think what Kubernetes has done really good is to find a good balance of abstraction. Like I never or almost never think about control plane or how to manage the nodes in Kubernetes because it just works. Like 99.9% of the time, I don't really think about it. And even when I do, I can, I don't know, like migrate to a different cluster and that's it. So I don't really need to understand everything. Most tools don't really like get this level of abstraction of like being that good that you don't really need to know what is happening under the hood. So it is tricky. But to be honest, I didn't play with enough like abstraction tools of Kubernetes, so maybe I need to play more and have like. What do you think, Kunal? Like, what is your take here?
I think definitely, as more abstraction is being provided, I think like for the end user, it may look simple, but it only has more complex things under the hood. So I think like, for example, if I when I'm teaching like data structures, people are like, Python is very easy to learn. Yeah, sure, that's great, but internally it's also written in like C++. So if there's no, like, no type defined, or whatever, no limit to integer size or whatever, it's easy for you, but internally the people who have made it
Yeah.
has been like challenging for them. So I think abstraction also comes at a cost. I mean, obviously there isn't like much control that many folks may have over the thing, and I think they choose to have that functionality, not being able to worry about the infrastructure and the Kubernetes part, and they can focus on just writing code and deploying it. But I think from a troubleshooting point of view, yes, it may complicate things a little bit, but we'll just have to see, the what kind of solutions come out, like you said, in the next 5 years or something. But yeah, Commodore for now, I think should be good.
Okay. Okay.
Amazing. This was great. Thanks, Itiel, for joining. For folks who are watching this, if you have any questions, make sure you leave in the comments below. You can also reach out to Itiel on Twitter, reach out to Commodore on Twitter. If you have any thoughts, you can share. You can also join their community, and I'll leave all the resources and links. You get starting with Commodore and some blog posts as well around Kubernetes troubleshooting in the description below. And yeah, it was a lot of fun. Thanks, Itiel, for joining, and I'll see you soon next time.
Thank you.
Bye.
See you, Kunal. Bye.